This presentation shares a UC San Diego library effort to expand access to medical library research training and make it easier to scale. The approach combines three core elements: structured search protocols, modular learning tools, and early experiments with AI-assisted support. The goal is to shift library research training toward a more scalable, learner-centered model. It begins by rethinking instruction, moving from traditional classroom formats to self-directed learning that supports users step by step. The first focus is on developing structured library research protocols. These guide learners through the research process in a clear, linear way. These protocols are then transformed into modular learning tools, adapted into multiple formats to support a range of clinical settings and users. Finally, the project explores how this design can support AI-assisted research guidance. Using ChatGPT, it prototypes a chatbot built on the search protocol to deliver step-by-step support for developing a literature search. Library research training has traditionally been delivered through live classroom sessions, either in person or online. While effective, these sessions are time-intensive and hard to scale. They're also difficult to adapt to learners with different goals, preferences, or levels of experience. There's a need for training that works beyond the live classroom, for learners who need research guidance they can revisit and build on over time. The objective was to create a scalable model for library research training. In this context, scalability means reaching more learners across programs, locations, and skill levels without increasing the need for live librarian support. A scalable model should work across formats, adapt to different learning contexts, and stay effective whether used by one person or many. These traits formed the foundation of the project's development. This approach centers on a structured library research protocol, a step-by-step guide through the full research process using library tools. It leads learners through a clear sequence of manageable actions, identifying information needs, selecting appropriate sources, conducting a literature search, and accessing materials. This process is supported by templates, taxonomies, and examples, providing structured guidance for self-directed learners. A key component is the literature search protocol. It presents a linear workflow that walks users through each stage of the search process, from defining a research question to developing and refining a search strategy. These steps can be difficult to explain clearly in a single class session. The protocol lays them out in a logical order that's easy to follow and easy to return to, especially for learners working independently. Let's look at the structural elements that makes the protocol easier to follow. The first is the information needs taxonomy, a visual guide that helps users identify what kind of information they're looking for. Once the need is clear, the taxonomy connects it to the right source type. It doesn't just tell users where to go, it shows them why and when to use each resource. Another structural element is the set of search heuristics, simple rules and shortcuts that guide users in shaping their search strategies. These help learners make decisions more easily and handle common challenges during the search process. Another structural element is the set of fill-in-the-blank templates. These give learners a clear and organized way to draft their search strategies. Finally, the protocol includes worked examples, realistic walkthroughs that show what each step looks like in action. These examples reinforce structured learning by modeling the search process. Altogether, the structured elements of the protocol help learners build search skills more independently and with a clearer sense of the process. The protocol is also designed to reflect how people naturally think and solve problems based on dual process theory. This theory describes two types of thinking. System 1 is fast and intuitive. System 2 is slower and more analytical. The protocol supports System 1 thinking through heuristics and visual cues. These help learners make quick, intuitive choices. It supports System 2 thinking by breaking complex tasks into a clear step-by-step sequence. It provides structure for more deliberate, analytical problem solving. This balance may help reduce cognitive load and make the research process easier, especially for self-directed learners. Let's look at the second part of this project, transforming the structured protocol into modular learning tools. Distinct parts of the protocol were adapted into standalone training resources. Each focuses on a specific research task and can be used independently or combined into a learning sequence. Each module is then developed in multiple formats, such as videos, web guides, quizzes, infographics and microlearning content, and instructor slides with scripts. This modular approach offers flexible, reusable guidance designed to work across different formats, audiences, and learning needs. These tools also support use in instruction, reference, and outreach. Let's take a quick look at the types of tools available. The tutorial videos support users learning on their own. Each one walks through a specific step of the research process. The web-based guides are available anytime for quick reference. They're helpful when learners need a refresher. The quiz helps learners check their understanding and reflect on their skills. It also gives personalized suggestions for what to explore next. Short visual content like infographics and microlearning materials work well in newsletters, outreach, and social media. They're ideal for quick review and learning. Instructor-ready slides with scripts are also available, so faculty can bring this material directly into their teaching. This modular approach is built for flexibility and scalability. The materials support a range of learning styles, goals, and timelines, and they work across instruction, reference, and outreach. They can be embedded into courses, used in consultations, or shared through outreach. They're also discoverable independently through search. This model shifts from a librarian-led approach to a learner-driven one, supporting scalable research training without requiring real-time librarian involvement. Learners can access and reuse the content at their own pace as their needs evolve. This flexible model also lays the groundwork for exploring how emerging tools like generative AI can support library research training. Built on the structured protocol, a prototype chatbot was developed to guide users step by step through the literature search process. A prototype chatbot was developed using OpenAI's custom GPT tool. The search protocol was uploaded as a knowledge file to provide step-by-step guidance. User engagement instructions were also written to shape how the chatbot interacts and supports users through the search process. For instance, limits were built in to prevent the chatbot from giving direct answers or straying off topic. Its role is to guide, not complete the search. Because the structured protocol was already clear and linear with worked examples, it translated well into an instructional script the chatbot could follow. Instructions and materials for developing this custom GPT are available at the link provided. This setup followed guidance by Levy and Perez Albertos, who outlined how to configure a custom GPT using defined interaction rules. A chatbot prompt developed by Cho also helped inform the approach. The chatbot follows the same process as the search protocol to support users step by step. It starts by asking users to define their key concepts one at a time. Then it guides them to brainstorm and compile keywords and controlled vocabulary terms. Next, it introduces core search techniques like Boolean operators, phrase searching, field tags, wildcards, proximity searching, and filters. At each step, the chatbot helps apply these techniques to build a complete and structured search query. Next, you see a short demonstration of the chatbot in action. This early prototype isn't yet available to users, but it offers a preview of what's possible. There's no audio, just a visual walkthrough of how it works. Early observations were encouraging. The chatbot was able to guide users through the structured search process and showed potential to support more independent learning. There were also challenges. The chatbot sometimes combined steps and prompts or gave inconsistent responses. This highlights a key limitation. Generative AI doesn't always follow a fixed instructional sequence or use consistent language. Still, this pilot showed that a structured protocol can provide a strong foundation for developing AI-assisted tools in library research training. Looking ahead, library design protocols and teaching practices can help shape responsible AI-driven tools to support scalable research guidance. Wrapping up, here are early evaluation highlights and future plans for this project. The structured protocol and modular tools received positive feedback from medical classes for their clarity, step-by-step guidance, and flexibility. The AI chatbot prototype showed promise in supporting guided search instruction. Next steps include assessing learning through quiz results, video analytics, and feedback from training sessions. The chatbot will continue to be refined to better follow instructional workflows. Over time, this approach may support scalable, self-directed research training across different learning settings, needs, and platforms. This project brings together three integrated parts: a structured library research protocol, modular learning tools, and an AI-assisted chatbot prototype. Each is designed to support scalable, flexible research training rooted in library practices. The model can be adapted across disciplines, and the supporting materials offer more detail if you'd like to explore further. And just for a poetic close, here's a summary in the form of a haiku. Structure guides the way, modules teach, chatbots relay, grows in wide array. Thanks for watching.